Hello, my dear students. I am B.S. Pandey, and today we are in lecture number 27. Lecture 27. This lecture is very important, my dear student, because we'll solve numerical in today's lecture. Okay, of the second chapter, same unit, electrostatics. Today we will start our lecture with the mixed combination and with a numerical first, and then we will proceed for the mixed combination. The 2 or 3 simple numerical we'll take today. We have studied the formula for series and parallel combination. I would suggest you to go back my last video lecture and then you will find the formula. Today with the example, find the 4 question I'm giving you: C equivalent, second Q total of the network, third potential at each, and fourth potential, and fourth is charge on each capacitor. This is also the each capacitor. The fourth thing you have to find in all circuit in given network. Okay, my dear, I'm giving you few networks. For that networks, you have to find these 4 quantities. A very simple network today we are taking. Okay, all students, you will be able to understand this one. The first question here, this is the 2 capacitor. Okay, suppose it is 10 microfarad and this is also 10 microfarad. It is connected by 50 volt. Okay, it is connected by 50 volt. Now the question is very simple. You have to find this all. The first, you can find the equivalent capacitance. Formula you know. For series, it is C equivalent. It is equals to C1 C2 by C1 plus C2. Okay, so C1 C2, that is 10 microfarad into 10 by 20, that is 10 by 2, it is 5 microfarad. So the C equivalent you have calculated. For 2 capacitor, identical capacitor, we also know the formula directly: C by 2, C by 2 for 2 identical, and here C is the capacitance of one capacitor, since all the identical, so capacitance, and it is 10, so the 10 by 2 directly you can write the 5. In examination, if you have been asked, you can write directly by simplifying this one. Now the second one, so this is the first question. A C equivalent you have calculated. Now the total charge, we know that Q total equals to C total into V total. Okay, so the Q total, it is C total, how much? 5 microfarad into V total, how much it is given? 50 volt. So it is 250 micro, this micro, and farad into volt, it become coulomb. Okay, so it is 250 microcoulomb. It is the total charge, and this total charge will start flowing through the network, through the circuit from this. Okay, this is the total charge. Now you have to find the potential at each and charge on each. Okay, my dear students, can you tell me, if this charge Q is moving through this capacitor, how much charge will here and here? Answer is yes, the same charge will move through each capacitor. In series, we know that charge remain constant, flow through the network. So here the charge will be, so the answer of fourth, that is D, we can write it is Q, which is 250 microcoulomb through each. capacitor. Now the third one, we have to find the potential at each. As we know that Q is equals to CV. For this capacitor, we can apply this formula to find Q is equals to CV, and C is 10. So the V will be Q, since here the Q is, we have calculated already, 250. Okay, and C is how much? 10. So it will be 25 volt. Since this had the same specification, so here again, if it is 25 volt, this will be also 25 volt. Remember students, after solving, you should be compare your answer, verify your answer. If it is 25, the total will be 25 plus 50, and it is 50. So answer is correct. In this way, you can find the answer. Okay, student. Now I'm giving you homework, and then we are moving for another example. Okay, I hope you have written. I'm rubbing. Now the next question, and this question will be your homework. I'm using here capacitor 3 microfarad and 6 microfarad. Okay, and here 20 volt battery, it is connected. Okay, na? 20 volt. The same 4 questions it is given. The first homework, the second homework, 3 capacitor are joined with the battery, and 3 are giving you here 2 microfarad, 4 microfarad, 3 microfarad, and 4 microfarad. Okay, my dear students, and this is 10 volt. You have to find again that all the 4 quantities, 2, 3 and 4. Okay, 2, 3 and 4 microfarad connected with the 10 volt battery. Now this is your homework. Now we are moving for the next example. I'm rubbing this one. Okay, so the next example for the parallel combination. Here the question is, the 2 capacitor you have of 10 microfarad again, connected by 100 volt. Okay, this is 10 microfarad and this is also 10 microfarad with the 100 volt. Charge will start flowing from this one. We have to find first equivalent capacitance. So a equivalent capacitance, here the formula we are having, C equivalent equals to C1 plus C2 for parallel. So the C equivalent will be very simple, 10 plus 10, it is 20 microfarad. Directly you can also write, we know that in parallel combination for 2 identical capacitor, the formula is C equivalent equals to N into C. What was? C equals to N into C, the C equivalent. N into C. Here N is how many capacitors are there? 2 capacitor of identical value, it is 10 microfarad. So 2 into 10, how much it will be? 20 microfarad. Okay, so we are having the answer here, the 20 microfarad. The next, we have to find the total charge. For Q total, we know that C total into V total. Okay, so the C total we have calculated the 20 microfarad, and the V total it is given 100 volt. So how much it is? It is 2000 microcoulomb. Okay, 2000 microcoulomb, the total charge we have calculated. Now here the total charge, it will start moving and it will break in 2 parts. Okay, am I correct? Yes, the total charge will break in 2 parts, but you know that the potential remains same across this one and across that. So for both the capacitor, the potential is how much? It is 100 volt, 100 volt over here and 100 volt over here also. Here you are having the potential, here potential and capacitance also. So you can find the charge as it is C Q1 equals to C1 into V1. So the C1 is 10 microfarad and V1 it is 100 volt. How much it is? 1000 microcoulomb, and for 1000 again. So the total charge, if you add here 1000 and 1000 charge, so total it is 2000, and we are having the 2000. So we have calculated here the voltage was in parallel, okay, 100 volt on each. Okay, my dear students, now I'm giving you the homework. You can note down this one. Now the homework. Third homework I'm giving you. So this third homework, here the 5 microfarad, 5 microfarad and 5 microfarad. Okay, here the 150 volt we have connected. You have to find all the 4 quantities. The fourth question. It is connected by a battery of 20 volt. Okay, my dear student, and the value of capacitors I'm giving you here: 2 microfarad, 3 microfarad, 5 microfarad. Okay, you have to find all the 4 quantities. This is your homework, 2 homework from parallel combination. Now, my dear student, we are going to solve now mixed combination. Okay, from the first question you have to be concentrate to learn. We are talking about the mixed combination. Okay, so I'm starting. If we connect 2 capacitor of C and C, identical capacitor, about this terminal X and Y, I'm asking the answer. What will be the capacitance? Remember, you have to give the answer orally. You are not supposed to use pen and paper. You have to give the answer orally. You have to be very smart while solving this question. Then your concept will build up. The 2 capacitor of C and C. What was the formula? For series combination, the formula was for identical capacitors, since here we are using the identical capacitor. So the formula was C equivalent is equals to C1 C2 by C1 plus C2. Okay, for series combination, or C by N if identical. The 2 capacitor C equivalent will be C by N. How much? 2. This is the answer. Okay, now the next question I'm giving you. The first question successfully you have solved. The second question I'm solving. I'm just enlarging this network. Remember, be careful. I'm enlarging this network already. Okay, suppose it is 2C and 2C. Then what will be the answer? What will the answer? And the answer is yes, this 2 will be C. Now, if I have added another capacitor of C, now about this 2.1, what will be the equivalent capacitance? Now student, you can see this 2 was connected in series and it is not going to be changed. It is in series even now. But another capacitor in parallel, it has been connected. If we will solve, try to solve, this is the one capacitor. This is the one capacitor. It is C. 2C and 2C will be C, and another capacitor now joined in parallel. Okay, in parallel. And how much it is? C. If 2 capacitor of capacitance C and C identical are connected in parallel, then what will be the answer? The answer will be C equivalent will be to C. This is the answer. Yes, it is clear. Yes. Now the third network I'm giving you here. Two C, 2C, and this was C. Okay. Now I'm connecting here another capacitor of 2C. Now this is the Y terminal. Can a student tell me what will be the equivalent capacitance? Remember, up to here you have solved already. Up to here have been solved, and it is 2C. Another capacitor, it is connected, so the equivalent circuit will look like this one. It was 2C, this total. This one is the 2C, and another capacitor, it is connected in series. So it is 2C and 2C. Again, the answer will be C. Try to remember, this was the C now. So this will be the C. So the C equivalent is C. In this way, my dear student, you can do practice for number of questions or the zero level. You can say this is the zero level question. Now I'm giving you the quickly the networks, and you have to tell the answer. Okay. Tell me the answer between X and Y. If it is 2C and it is 2C and it is C, what will the answer? Yes, the answer is all the three capacitors are connected in series. Remember, don't be confused that this is in series and this is parallel. Okay, you can see if the charge will enter from X, the total charge will go to this 2C and then this 2C and then it will come to this C. So all the three are connected in series. If you are thinking about the parallel, then this is connected in parallel with this one, then what should be the circuit here? This is 2C and 2C. Then this C, if this is the one circuit, then the terminals, find out the terminals. The one terminal is this one and the another terminal is this one. If this is parallel with this one, then it's one terminal of this capacitor, one terminal is this one, it is connected with the same, and another terminal also should be connected with the same. And if you are taking any of the common terminal as first terminal and the second terminal, then only this two will be considered in parallel. Otherwise, this is not in parallel. Okay, I hope you understand. So this is in series. You have to find the equivalent capacitance. I hope you can solve. Let me leave it as your classwork. Now the next. Okay, my dear students, you have to find the equivalent capacitance. All are the C. What will be the answer? This C will be the C by 2. Okay, these two C are in series. First, whenever you got the such type of question, try to solve the simple network, and simply you can see these two are in series. Then if there will be one capacitor, then this is parallel, and then this will be the one capacitor, and then it is in series with this capacitor. Okay, so it is C by 2 and this is parallel, so C by 2 plus C, that is 3 by 2C, and then in series. Okay, so 3 by 2C into C divided by 3 by 2C plus C. Okay, and that will be the answer. I hope you are getting. You can repeat the video to listen me again. Okay, I'm going to expand this question. Now the next class work. This is for your practice. Remember, my dear student. This is the C. Now what will be the answer? Okay, whatever you got the answer for this network, that previous network, you have to just take this C as your parallel capacitor. With this particular network, this C will be in parallel, and then you can find the answer. That will be the correct answer. Student, if you will be asked to find the charge on each capacitor, potential on each capacitor, the total charge and the total capacitance, and total capacitance you have been calculated. If I'll give you the values, could you find the total charge and charge on each capacitor and potential on each capacitor? Okay, now we should not just kill the time. We should learn something which is very important for your board examination. Okay, so the next question I'm giving you, you have to find out the potential on each one. So these are the some mixed combination. There will be several more combination you will learn. I'll tell you just now. You have to find the four things that you have calculated in the very first question. The four things you have to find. First, write down C equivalent of this network. Second, you have to find the total charge. Third, charge on each capacitor. And fourth, potential on each capacitor. Now I'm giving you the value. Okay, this is 20 microfarad. This is 20 microfarad. I'm not writing the unit, but I'm telling you. Okay, 20 microfarad, 20 microfarad. This is 10 microfarad. Okay, this is 10 microfarad. This is 20 microfarad. And this is 100 volt battery. You have to find charge, potential, that is on each capacitor, net capacitance, okay, all the things, and the total charge of the network. How you will solve. So the first you should try with the net capacitance. Here the 20-20 are series, so this 20 and 20 will be 10. Now this 10 and 10 will be in parallel, so this will be 10 and then 10 will be in parallel, and parallel that will be added, so the 10 plus 10 will be 20. Now this total become 20 and this is series with the 20, so the 20 and 20 again in series will be 10. It means the total C equivalent, it is 10 microfarad. Second, total charge, Q total equals to C total. How much it is? 10 microfarad. V total, how much? 100 volt. Total charge 1000 microcoulomb. Now you can find the voltage. Okay. Third, and charge. How much charge is flowing? 1000. Okay, 1000 microcoulomb. Here, what will be the amount of charge? The total 1000 will reach to this one. So you can find the voltage over here. Okay, so the voltage, suppose it is V1. So the V1, you can write V1, it is Q by C1 or the 20. Okay, how much Q? 1000 by 20. Okay, so it will be 50 volt. The total potential of the network is 100 volt. You can see it is connected 100 volt, but 50 volt drawn already over here. It means if you divide this network in two parts, one is this one and then another is this total network, what will happen, student? If 50 volt has been drawn over here, then 50 will be remain for this section, and for this section if it is 50, it means this particular two terminal will get the 50 and this upper two terminal will get 50. I mean equal potential. If it is getting 50, how much charge is going? How much charge is going from this point? If at this point the charge reach 1000, then there will be 1000, and after that the charge will divide from here. The charge will divide from here and here. How much charge is going here, we don't know, but we can calculate. Here the capacitance is 10 and potential is 100. So the charge, suppose it is Q1. Okay, suppose it is Q1. So we are going to find out the charge reached at this capacitor. We can write Q1 equals to C into V. How much potential over here? It was 50. So it is 500 microcoulomb. How much charge is going? 1000. But 500 gone through here. It means rest charge will move through here, and rest charge, if it is the 1000, then rest charge will be 500, since 500 gone through here. So the 500. If 500 charge gone through here, then you can find the potential over here also. Suppose this potential is V2. This is V3. Okay. So the V2 can be written to find the potential. You know that the charge remain same for both the capacitor, which is 500. So V will be 500, that is Q by C by 20. Okay, and it is 25 volt, and here again 25 volt, that will be the total 50 volt. In this way you can see you have calculated all the things which was asked to find. Okay, my dear students, another question I'm giving you for homework. Okay, kindly note down. So I'm giving you the question here. One question which is in your NCERT student, if you will open the NCERT book, you will find one question. I think you should solve that question by yourself. Okay, I'm giving you homework. For the network, there is only one question. It is mentioned in your NCERT. This is the battery. Okay, 6, 3, okay, 2 and 2, 10 volt. These all are in microfarad. Remember, due to the very less space, I'm writing here the digits. Microfarad, 10 volt. You have to find all the four things. Okay, four things you can write. It is one, you have to find the total capacitance of the network. Second, total charge of the network. Third, charge on each capacitor. And fourth, potential on each capacitor, my dear student. Okay, now one more question I'm giving you. This is another homework. I hope you can solve. The number of questions I have already mentioned in my assignment, as I told you time to time to solve my assignment. A, B and C. Here the 2 microfarad. 2 microfarad. Okay, my dear student, you have to find the potential. The first question. C equivalent between A and B. A and B. Okay. C equivalent between A and B. To if this is the first question. B. If 10 volt applied between A and C, find total energy. Okay, that is the stored potential energy of the network. Okay, my dear student, this is your second homework. Remember, student, the energy stored we have studied for the capacitor. Actually, that energy can be lost, and the capacitor, when discharged, it loses energy, and that energy lost in basically two important form you have to be remember. One, it is heat energy, and the second one, it is electromagnetic energy or the electromagnetic wave. Actually, that loss in energy we use for our proper, okay, uses in proper manner to produce electromagnetic wave that you will study in circuits, okay, in AC circuit. So this is all about today lecture, my dear students. Thank you.